Hello friends, welcome to Lakshya's Club. Today I'm going to show you how to derive the three main equations of motion. So, equations of motion are used in physics and there are three equations of motion. The first one is v is equal to u plus at, where your v is the velocity, is the final velocity, u is the initial velocity, a is acceleration and t time. Second one, v square minus u square is equal to 2as, where v is final velocity, u initial velocity, a acceleration and s distance. Third, s is equal to ut plus half at square, s distance, u initial velocity, t time and a again acceleration. So let's begin with the derivations of these equations by the calculus method. So let's start. The first equation is v is equal to u plus at. So to derive this by calculus method, we have to write a is equal to dv by dt. A here is acceleration, dv velocity and dt time, differentiation. So after cross multiplication we get dv is equal to adt. So in this we have to put integration. Integration sign is like this. We have to write dv under integration and we have to write uv like this. U means initial velocity and v means final velocity. Here we also have to put same integration, but here we have to take a outside. Taking a outside, dt inside, 0 to t. Then when we remove integration, we get like this. After this, we have to solve. V minus u is equal to a t, as a t minus 0 becomes same t. So v minus u is equal to at, so v is equal to u plus at. So this was the derivation, easy, for the first equation of motion, that is v is equal to u plus at. Now I'm going to show you the second equation of motion's derivation, that is v square minus u square equals to as. So let's begin. So v square minus u square, we have to take same, a is equal to dv but as you can see in this equation we need s also, so we have to multiply both the sides, that is the numerator and the denominator, by ds and ds, just like this. So we get a equals dv multiplied by v into ds, divide by ds. So till now it's clear. Then we have to cross multiplicate both the sides and we get ads equals v dv. Ads equals v dv, and then we have to put the integration sign on this. When we put the integration sign like this, ads equals v dv. Ads we have to take from 0 to s and v dv we have to take from u to v. It's right. Then we come to the next step, which says that we have to take a out. So when we take a out, only s is left, so we can write s like this, s0, and then v dv, we don't take v out. Instead of that we write v square by 2. V square by 2, we have to write it v square by 2 and then upside v u. Then we come on our next step. This step we have to change the values that are given above and below. So for this, here you can see that it was s minus s0 is equal to v square by 2 vu. So now here you can put like a, then s, as s minus 0 becomes s, v square by 2 minus u square by 2. Then we take 2 as LCM and send 2 at the other side with as. So it becomes 2as equals v square minus u square. So we can write, therefore v square minus u square equals 2as. This was the second equation of motion proved by the calculus method. Now we are going to prove the third equation of motion. Let's start. Third equation of motion is also kind of simple equation which we have to convert. So let's start. The third equation of motion is s equals ut plus half at square. This is the equation, and then we have to put the integration, but before integration we have to v is equal to ds by dt, as velocity is equal to speed upon time, ds by dt, and we do cross multiplication, we get ds is equal to vdt. After ds is equal to vdt, we put the integration sign, and we put the integration sign 0s above here, and in equal to sign we write the same thing but taking v out, and in this case we write u plus at instead of v, as we have proved in equation number 1 that v is equal to u plus at. So after this we come to our next step, but before that we have to put the upper sizes and the lower sizes of this. So t we can put 0 t. Then the next point comes where we have to write about the next thing. So here we can say that s will be equal to, now you have to do it like an integration 0 t, so you multiply u dt here, and then you plus again integration sign at dt. This is the next step, and then you have to write s is equal to ut plus a. You understand, ut plus a will be with us, and then the integration sign, and inside we have to write t dt. Okay, then after this step it's really important to do the same step as we did in the previous equation. S is equal to ut plus a t square by 2. So s will be equal to ut plus half at square, and this is the third equation of motion, and all the three derivations of the equations of motions are completed by the calculus method. If you like my video, then please subscribe into my channel Lakshya's Club. Thank you, and watch it later again.